Nicola Ferro, Panagiotis Filianos, Maria Maestro, and Giorgio Maria Di Nunzio. And the presentation will be by Vittorio Carmignani, Panagiotis Filianos, and Mirko Biasini. So
Hi.
the screen is yours.
Yeah, can you hear us, first of all?
Pardon?
Can you hear us?
Yes, yes. Please.
Okay, so it's clear.
Go
Okay,
ahead.
so now let us present. So we'll set this up. If you can.
We have to share the screen.
Yeah. And then share the sound also. Share the sound also.
Share the sound.
Yeah.
Okay.
And then it's done. All right. Presentation.
Okay. Nice. My computer is just. Okay. No.
Give us a second.
Okay.
Great.
Do you see the screen?
Set up this one.
Yes, yes,
nice.
we see everything.
Seems,
Go ahead, please.
Okay, so hi, I'm Panos, and I'm here to present the paper about FullBrain. FullBrain is a social e-learning platform where students study together, find personalized learning material, and connect with top companies. But we're going to be focusing on the first two parts of this, that is studying together and connecting with finding personalized learning material. But let's understand what a FullBrain is through seeing the context of what exists out there today in terms of e-learning platforms. So on one side, we have lifelong learners, which they primarily use massive open online course platforms, things like edX, Udemy, and Coursera, but these platforms have some trouble engaging their users. So we see that about 88% of the users in 1 year are not going to show up in the next year. Now, FullBrain doesn't address this segment of people. It primarily goes for science, technology, engineering, and mathematics students. And let's see what tools they are using. And we're going to analyze these tools through two axes. First of all, is how social a tool is. And then second of all, how much it's designed for learning. So currently, the primary solutions that these students are using are university platforms, things like Piazza or Moodle, that are often case supplemented with tools that are made for more immediate collaboration, things like Slack or Teams. Now, it's often the case that students really want something that is more immediately social. They want to connect with the students that they know and that they trust. And as that's the case, then they often opt in for tools that are immediately social, things like Facebook groups or WhatsApp. Now, these tools are not designed for learning. As we see on the chart there, they're very, very social, but not designed for learning. So it's tough to share material and it's tough to find it. They're not made to send links and put relevant metadata. So students often have to use things like Google search to find really good material to study from. Now, from these things, what we understand is that, first of all, learning is better for students when it's social. We see this trajectory where students go towards more social tools. And then secondly, that for students, and we've seen that through dozens of interviews that we've had with students, it is harder for them to find resources. And it's clear here that the place that you want to be is this green rectangle. And that's exactly where FullBrain exists at. So let's see what FullBrain is. FullBrain is a social e-learning platform where STEM students collaborate, ask and get help, and share and find learning material. Now, FullBrain is a full-fledged social network. So let's see exactly what features are available there through its social graph. So of course, it has users, and users can connect with other people and follow them and see how they are learning. Now, each one of these users attends a university. They're university students. And each one of these universities has physical, real courses. Now, on these course spaces on FullBrain, there are specific course spaces for each one of them on FullBrain. Users can come in and they can follow these spaces, see how it is to learn on that course. They can post and ask questions and share thoughts, and other people can come in and interact with them, and they can share resources and pass their exams together. Now, as we have specific dedicated spaces for courses, we also have specific dedicated spaces for topics. So these are the places where users can follow and see all the learning activity for a specific topic, like neural networks, for example. Now, as we've seen before with the course spaces, here users can share resources and understand the topic together better, where other users can come in and rate these resources and see how good they are for the community. And then also they can ask questions exactly in the same format as we discussed on the courses. Now, of course, here on FullBrain, there are a lot of other entities and interactions, but for this presentation, we're focused on these entities where, as we said, it's we have users, we have courses, concepts, sources, and posts. Now, let's take a brief detour here to see what the architecture of FullBrain is like today. So when a user comes in on FullBrain, they get the website from the front-end server, and then they communicate with the backend, where we have a gateway and then a set of microservices that are connected with the databases through gRPC buses. The microservices that we really care most during this presentation are the search and the user microservice. So let's start with the search by talking about the social information retrieval system on FullBrain.
So of course, in a platform like FullBrain, things like the autocomplete for hashtags or the search bar or autocomplete for mentioning in posts are vital, right? These features. And everything is powered by our information retrieval system. Now, though, searching in a social network is different than usual search, let's say, because if I'm searching for Mirko, the guy here, then I would have 3 results, like ordered alphabetically ordered. But I don't know really this guy because it's irrelevant to me because it's really far in my network. I would like to see Mirko first. So what I do is that I use the distance in the graph to have what I want. So Mirko Biasini first, and which is more relevant to me, right? So what we do is that we implement this distance model in our 3 functions. So search, query autocomplete, and query suggestions. And now we're going to see how we order the results within these functions. So for search, we use this overall similarity, we call them, as a sum of topical similarity and user similarity, as a function of query, entity, and searcher user. So regarding the first term, we calculate it in 2 ways. So in case of concept, courses, and users, we use this function, where in the first term, there is we use partial matching. So we calculate the set of trigrams for the query, the name of the entity, we do intersection, union, and then we calculate the first term. Instead, for the second part, we use just the cosine similarity. So we're talking about the exact match between query and name of the entity. So we represent entities as vectors, then the query comes in and we calculate the cosine similarity between them. Then we use, for sources and posts, we just use cosine similarity. Now for the second part, instead the user similarity, we calculate, as we said, we use the distance in the graph between the searcher and the entity, normalized by the maximum distance in the graph. And this is because the nearer is the distance, the nearer is the entity to the searcher, the more relevant it is. Now for the autocomplete function is exactly the same formula, but the topical similarity is just use the partial matching. Whereas for query suggestion, there is no query input, right? So what we do is that we suggest past search entities and queries, as well as most search entities and queries in the last week to resolve the cold start problem and to make the user explore even more the platform. Now, of course, the system is implemented and we tested on the real website of FullBrain.org. And we saw that for search, for query autocomplete and query suggestions, the time to complete the request were way in the bounds that we set. So we say, okay, let's stress the system a little bit more. And we did some stress tests. And here the results were definitely worse. We did a lot of requests with parallel users, but this is due to the physical limitations of the machines and also other conditions that you may want to ask in the Q&A. Now let's talk about the gamification part.
So one of the main problems of social networks is the under-contribution. As a matter of fact, even a successful product like Twitter, only 1% of the user produces 50% of the whole content. And FullBrain faces similar issues. We observed early abandoning of newcomers, little contribution, which translates into little content for the users. To tackle this issue, gamification, which is defined as the use of game elements in non-game context, has shown very positive results to improve user engagement. The most used game elements are badges, leaderboards, and points. And focusing on leaderboards, these provide elements of reflection, comparison, and competition. They can follow two approaches, an absolute and a relative. And finally, to be effective, they need to be designed based on a specific audience and a specific context. Now, FullBrain offers a variety of contexts as well as a variety of different actions. And combining this different set of actions and contexts, we can generate a multitude of different leaderboards addressing different areas. But first, we need a point system. And to make a point system as fair as possible, we asked our users to assign an effort and the value score to each of the actions available in the platform. The effort score assesses the effort required to perform the action, both inside and outside the platform, whereas the value represents the value that the action brings to the platform and its communities. Then we combined these two scores and we computed the final point system where each action has an effort and the value score. And then the final one is computed as the sum of the previous two. So every time that the user performs one of these actions, he will gain the corresponding points. Now, to design the leaderboard, we said we can follow two approaches, absolute and relative. The absolute only focuses on the top players, in this case, the first top 10 contributors. So the active users is shown only if ranking in the top 10, whereas the relative leaderboard is focused on the active users. That's why in this example, the active users is centered in the leaderboard. And as the rank of the active user is 93, then the other contributors are ranked between 88 and 98. Now, through our experiments, we found two different solutions for concepts and courses that are both hybrid in the sense that they mix the absolute and the relative approach, but in a different way. So for concepts, we propose what we call a hybrid absolute design because it's mainly focused on the absolute leaderboard, the top 10 contributors on the top, and then the relative side is given only by the active user. Whereas for courses, we propose a hybrid 50-50 design, which equally combines an absolute leaderboard on the top with a relative leaderboard on the bottom. And through these experiments, we interviewed several users and they revealed that 73% of them prefer the hybrid absolute design among 4 possible options for concepts. And when asked to justify such a choice, they explained that in broader contexts, like concepts where they don't have real relationships with the other users, they only care about top users. They only want to see how top users learn and get inspired for them. Whereas for courses where they have real relationships, 75% prefer the hybrid 50-50. And this was justified because here, that as I said, they have real relationships, they want to see the top students, but they also want to see similar classmates. And this is for 2 reasons. First, because they want to assess themselves and see where they stand compared to the rest of the class. And secondly, because they feel more comfortable to approach similar students rather than the top ones or the best ones. And then finally, as one may expect, looking at the activities on our leaderboard, we observe that 55% of the activities are taken on the top users, and almost the entirety of them are taken within the first 4 positions. Now we'll show a quick demo about FullBrain.
This is the homepage of FullBrain. Here we have a home stream showing posts, questions, and resources. And these are selected based on the people, the courses, and the concepts that we follow. On the left side, we have the courses that we are currently attending. And if we click, for instance, on this page, we open the course Base di Dati 1 at the University of Padova. Here we can include, and I include a course. You can see that we already have 60 students following this course. Here we can add a post or ask a question, as well as share a resource. And finally, on the right side, we have the leaderboard showing the top contributors for this specific course. If we want to ask a question, then we select that is a question post. We can even ask anonymously. Here we can insert a title for the question, whereas below we can insert a description of the problem. In our case, we are trying to solve an integral, so it could be a nice idea to add the formula of the integral. And this can be done very easily using the math tool. Additionally, we can also share code. In our case, it's a Python code, so we select the Python language. We can copy and paste the snippet of our code. And finally, we can go ahead and ask what we are doing wrong on our code. and then share it with the rest of the class. So this is the homepage of FullBrain, where we see the home screen. But let's focus on the search bar, where we instantly retrieve the query suggestions with some past queries, search entities, and also some popular ones. But now, if you click on Vittorio, which actually ranks second, then by clicking again, it ranks first, since it has become the most recent one. Then by trying some auto-completion, I can still see myself, even if I wrongly type. So this is awesome, and this is thanks to the trigrams. Then by let's try the search function, like searching for Francesco. And we can see that there are a lot of Francesco users, but this is first, probably because I've included him and our distance in the graph is shorter. Then PCA, we see the concept together with some posts and some related sources. And finally, if we look for UniPD, which is already here, then we can notice that even if UniPD is not present in the results name, we are still retrieving them because we are using all entities related fields.
Okay, so hopefully you can hear me again. Let's move into the conclusions a little bit. So since October 2020, where FullBrain was released to the world, we have developed a social information retrieval system where you can search through multiple entities. And we have created a gamified leaderboard where we boost interactions within courses primarily, but also concepts. But we've also created a full-fledged social network. FullBrain is out there right now, has more than 500 students, more than 140 courses throughout 17 universities across Europe, and more than 1,500 concepts out there. But FullBrain is also, it has a business side. It is a startup in Denmark. We are the 3 co-founders. We have been ranked top 10% in Startup School of Y Combinator, the best accelerator program for startups in the world. Right now we are part of the Innovation Fund Denmark, the InnoFounder graduate program, where we have enough funds to be working on FullBrain for the next 12 months for sure. So now what is available here? We think that you all here should get your courses on FullBrain. So you can do that by visiting fullbrain.org/hey. We'll also send it on the chat. And you go there, you scroll down to the bottom, and you fill a very quick form to get all your courses on FullBrain. Yeah, that's pretty much it. We can really help you have a great custom solution on FullBrain. So that's the presentation. Thanks a lot for your attention, and we're glad to take any questions.
Thank you very much for your presentation. Questions? Time for one question, perhaps. I will ask a question. This is a social, mainly social approach to e-learning. Of course, formal institutions may require some specificities. Is there a way for merging these needs from the bottom on the social side and from the top, from the institutional side, so that this platform can support also?
Yeah, so I can maybe take this question, and then if you have, you can add also. FullBrain was built through more than 100 interviews. We're talking 1 hour, 2-hour interviews with students, professors also, as well as other stakeholders. Now, what we saw is that students have a really immediate problem. They really need a solution that addresses all these things, that they can go in, they can share material, they can collaborate with students, get rewarded in one place. Now, on the other side, what we saw is that university professors may have a little bit more of inertia because they have all these formal requirements. So the approach that we took there was that we are building this tool, we're moving from bottom up, we're addressing to the students, always in collaboration and with discussion with our university professor partners, so that we have a solution that it has proven itself, and then we can make these collaborations with universities and make sure that we have the right amount of people there so that we can sustain FullBrain as we are coding for these requirements. So as we are developing for these requirements that are maybe a little bit more special in terms of how you share material, in terms of how one can contact each other. So this is the approach that we've taken so far. I hope that it's clear. Yeah.
Thank you very much again to all the 3 speakers. And let's move to the next presentation, which concerns